As I said, my name is Mitch West, engineering manager at Yum Brands. Been with them for about 4 years, and throughout those 4 years, I've had the pleasure of witnessing and participating in Yum Brands' adoption of Temporal throughout the various microservices in our platform. So, who are Yum Brands? All right. As you said, 4 main brands: Pizza Hut, KFC, Taco Bell, Habit Burger. You've probably used their products. All of those brands are in various stages of onboarding to our commerce platform. Taco Bell's on it, KFC's on it, Habit Burger Grill's on it, and Pizza Hut is in process of onboarding at the moment. And we're also doing international market expansion for those 4 brands at the moment too. So when we talk about the commerce platform and what it is, there's 2 main pieces. There's the e-commerce side, which is a federated GraphQL API that our brands hook into. So they have their brand client experience either through mobile device or through the web. That makes API calls to our platform. Those are federated microservices, each with its own area of responsibility. But then we have a second piece of the platform called menu management, which is our administrative UI. And that's where brand business users can log on to and author menus, author taxes, author promotions, manage all of the master data for them to be able to transact on our platform. And Temporal has become a key piece of that infrastructure over the past 3 years. So zooming in on the e-commerce side of things, this is the Yum platform, simplified version of it, but it illustrates the point. We have several microservices within this GraphQL federated API, and you see I've tagged all of the different services now using Temporal for various use cases. If you were here last year, you might have seen our engineering leader, Matt McDowell, talk about the cart, store menu, order, and payment use cases. If you weren't here, I highly recommend you look it up on YouTube. Very good talk, and he goes into detail of how we took out a complicated state machine with our order service and replaced it fully with a Temporal workflow. So when you submit an order on one of our websites, what you're doing is starting a long-running Temporal workflow. But today, I'm going to talk about 2 new ones. So we got a couple of 2 new ones this year for our loyalty and promotion services. And I'm going to go over their use cases. I'm going to look a little bit at workflow design, and then I'm going to do a live demo, which when I was thinking through this presentation, I thought, how can I really wow the crowd? You know, show them, not just tell them about it, but show them what we're doing behind the scenes. And I thought, live demo, it's got to be perfect. And within 20 minutes of the keynote yesterday, I watched Snake being played in a live demo on Temporal. So this will not be Snake. It's not as fun as that, but hopefully you find it as interesting as I did writing it. So first, loyalty, which if you ask Gemini what loyalty offers might look like for chicken, pizza, burgers, and tacos, this is what Gemini will give you. Continuing a long tradition of Yum using AI image generators in our presentations. The loyalty use case is very simple. Zooming in on its piece of the platform, our order service makes calls into our loyalty service for point earn and burn, offers, other loyalty operations, and our loyalty service itself acts as a almost like a lightweight gateway to 1 or more loyalty providers, depending on the brand. And in this case, we onboarded a loyalty provider this year that had a bit of an idiosyncratic API that required us to sync all of our stores to their API. Every transaction we send to them was scoped to a store level, and so all the billing was there as well. So we had some considerations. The biggest one was like timeliness. How quickly do we need to do this? Well, in our case, stores are authored in our menu management platform long before they ever start transacting on our e-commerce platform, so we've got time. It doesn't need to be quick synchronous request every time we create a store, immediately created in the loyalty provider. We wanted resilience. We wanted to not have to frequently troubleshoot this job. We wanted the flexibility, mainly giving our support resources and our developers the ability to start, stop, modify schedules at will without having to do so in code or without having to engage our site reliability engineers, who are lovely, but they're very busy people. We did look at some alternatives. We talked about maybe Kubernetes crons or Azure Step Functions, but Temporal was a bit of a no-brainer because we already had it within the platform. So workflow shape, not going to spend a whole lot of time on it. Very simple. It is literally just a scheduled start. 2 activities within the workflow. We fetch the stores from a paginated API from our store menu service, and for each store in the list, send them to the loyalty provider's API. Not very controversial, but the reason I mention it is I'm going to show you how schedules later can be layered on top of other temporal primitives to really control the execution flow of your workflow. So moving on to promotions. Promotions, a little more interesting. In this case, our promotion service does 2 things, right? It does calculations and tracking. First thing, during cart execution, when cart adds items or removes our items from the cart, or a user adds a promo code, they will make synchronous calls into promotions, and based off the contents of the cart, promotions will respond with a given discount, provided it meets the requirements, right? Pretty simple. Order as well will make calls into promotions. Redeeming, we can track redemptions down even to the customer level. And so all of that is housed within the promotion service. And then the third piece is menu management. They author the promos going into the promotion service. And at the moment, those promotions were pretty simple. Promo code, list of requirements, list of discounted effects, right? Well, this past year, we got a use case from one of our brand partners that said, what if I want individualized codes, or what if I want a batch of promotion codes that all have the same promotion behavior, but I want millions of them. I want to be able to issue these out to a bunch of customers. I think if you've ever done like T-Mobile Tuesdays or something where you get a push notification and an individualized promotion code to your device, that's the idea. And in this case, we're talking sometimes in the order of millions of codes at a time. So, considerations, infrastructure costs. I mean, a naive implementation, you could just shove these into RDS, your Postgres instance, as quick as possible, and handle the CPU or scale your RDS instance appropriately. But that's additional authoring or infrastructure cost. And then how do you orchestrate authoring, right? You're not just handling one of these, but we have multiple brand partners who could all be doing this at one time. How do you ensure that their updates aren't processing at the same time and causing surge traffic on your database? And then, of course, resiliency, which there's been a lot said about resiliency with Temporal this week. I think you very well know that the out-of-the-box retry functionality, very useful. So workflow shape. Where we started looked a little bit like this. There were 5 main activities. We would generate the code group, which was like a header level record. We would generate the batch codes within the workflow. We'd publish those to RDS. We would update the batch and then send an event out. And the first iteration of this, we kind of had some learnings. It wasn't the best implementation. We were batching from within an activity, meaning we had a long-running activity that in and of itself had to have error handling and didn't leverage Temporal's out-of-the-box retry functionality, and also could lead to failed states. Somewhere in the middle of our authoring, if we failed, we would end up just stopping the workflow, and we had impartial batches of codes written to the database. So next iteration of this is to shrink that activity, smaller batches, executed multiple times, just on a loop, until the complete batch is done. But that still doesn't solve the problem of how do you herd multiple admin users creating these batches all at once. And that's this final iteration. So in this case, we're leveraging a parent workflow as a bit of almost a queue. accepting these authoring requests and spawning child workflows to process them serially instead of in parallel. So rather than talk about it, I'm going to switch over here and I'm going to show you. All right, can you see my screen? Yes. All right. Perfect. So what I have here is my very simplified version of our what we offer, our admin UI. You can specify a count of these batches you want to create. There's a few different buttons here that do different things. You can search a batch that you've created. And why don't we go ahead and just see what happens when I push this button. Okay, we get a little toast message that says the workflow was created. Let's jump over to Temporal UI and do a refresh, and we see we now have a running workflow. It's actually already done, but let's click into it and see what it did. So we had a few different activities. We executed our write codes a couple times. Then we did our write to S3, and then eventually sent our Kafka event. Well, if this is our first iteration, and let's say I'm a really click-happy user or an enterprising QA analyst, and I want to see what I can break, I'm going to just sit here and tap, 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 right? And what do we get over on the temporal side? So we get multiple running workflows, and we haven't protected our database infrastructure at all, right? All of these are executing in parallel, and it's almost like we're just slamming in as many as possible, which is what we were trying to prevent. So what do you do instead? Let's hop on over. So I have this other button. What does it do? So this is safe create. Let me push a couple, and let's do the same thing. I'm being ornery. I'm a QA analyst. I really want to try to break it. So what happened when I did that? Okay, we see a new workflow pop up here. This is the parent promotion code workflow. And you can see in the execution history down here several calls to this add code gen job signal. And what that is doing is signaling in a new job to this parent workflow. And those are added to a queue. It's really just it's just an array that gets drained from an infinite loop, or as long as there are objects in the array. And for every single one of those that's popped out, it spawns a child workflow that processes serially, not in parallel. So now we are controlling the throughput of our users' behavior and ensuring that we've protected our database infrastructure through a very simple setup. But let's go even further. All right. We're going to let that one continue. So I've got another button here. Schedule. What in the world does that do? So job accepted gives me an ID. Let's jump over to Temporal. I see a new workflow pop up. And this one has a different type than the other one. This is create pending promotion codes. I click into this pending promotion code workflow, and what do I see? I see the signal that adds the job, but then I also see this sleep timer. It's set for a minute. But what in the world is this workflow doing? It's just sitting here. It's not executing at all. Well, if I go over to schedules, I see that I have a pending promotion schedule. It's currently paused. Let's unpause. And while I do that and I wait for it to kick in, I'm actually just going to show you this schedule real quick. I'm going to show you how simple this UI is to create. Give it a name. You define the type of workflow you want it to run on the schedule. You give it an ID, a task queue to execute on, and then you have several options for schedule. So interval, days of the week, days of the month, or if you're just a fan of cron strings, you can do that too. Now, why might you want to do this? Well, in the case of our infrastructure, you might have heard of a little thing called Taco Tuesdays, right? You probably get, some of you, if you have the app, you get push notifications. Well, the last thing we want to do is be authoring work that doesn't need to be done now while we're trying to make sure our services are highly available for a surge of traffic right at 4 p.m. Central for everybody trying to get those limited 20,000 codes, right? Those 20,000 discounts. So what you can do, and I'm sure this is run by now, so I'm going to jump over here. I'm going to click on this schedule. So now we see something has happened to our pending promotion code workflow. So we had our queued job, our timers were executing, and then what else do you see here except for a get pending promotion job, and that is a update. So what's happening is the schedule is kicking off a job that has an activity to call workflow update, grab a job from the pending promotion workflow, mutate that workflow, grab the job from it, reduce it from the array, and then kick off a child workflow of its own to actually process that. So what that means is not only can you queue up these jobs, but then you can precisely control with schedules when they execute. So if you want to do it in off hours, or if you want to exclude days, if you want to exclude Tuesday altogether to make sure that you can serve your surge traffic, you can do that with very simple temporal primitives. All right, very last thing I'm going to do. I am going to take this schedule and I'm going to edit it. I'm going to change the workflow type. So new workflow type, schedule pending promotion codes, pausable. What in the world is that? So I'm going to go back over here to my promo generator. I'm going to schedule a few jobs. We've kicked off our pending promotion code workflow. You can see those signals being added to it. Our timer, we can see the scheduled job kicking off, getting the pending promotion. And then if we click into that schedule, we can see it grabbed the job. It spawned the pending promotion code pausable workflow. It did it again. It hit the workflow update, grabbed the next job, spawned the child workflow. But oh no, we just got a call from Taco Bell. They're doing an emergency promotion. Okay, so I hit the pause button. What did that do? Let's go back. Okay, we see a new signal, set execution state within our scheduled workflow. Let's click out of that and let's click into the child workflow and see what happened. Okay, it looks like that signal was forwarded to the child execution, and now your child execution is waiting in a loop. It's going to wait till you let it know that it's safe to execute again. So layering all these things together, what you have at the very end of it is built-in queue, a scheduled job to drain that queue, and then an emergency red stop button if you need it, if you've ever got any production issues that come up. And let me just unpause it. We can see that executing. We see we got our signal. Go into the child workflow, and it was forwarded the signal as well, and it continues on writing codes and then finally completes. And the last thing I want to show you is how simple this all was to do with code. So not counting the UI, I wrote the workflow piece of this and the server piece of this in just a few hours, right? So walking and stepping through the create promotion code parent workflow, you can see the very first thing I've done is define a signal. Very simple. Add the code gen job with an ID and account. This is how many codes I want to generate. Within the workflow itself, I'm setting a handler. This is what I want you to do when you get that signal. All it's doing is pushing that job to an array and then a loop. As long as that array has stuff in it, We're going to take the jobs out, we're going to execute our child workflow, and then as soon as we're done draining that array, we're done. Right? Very simple. Moving on to the next thing we did. In this case, the pending promotion codes job has a new handler. This one's the workflow update. So it's got the first handler for adding the code gen job, where it'll just queue up the jobs in the array, and then the handler for getting pending promotion job actually mutates it, right? Shifts pending jobs out of the array, returns it to the caller, which in this case was that other workflow, executing that in activity, and then just sleeping for a minute, checking again at intervals if it's got no jobs left, at which it will close itself. And then the last thing, the pausable workflow. So this one uses an additional signal, this set execution state that we saw within the UI. And the only thing special it's doing is keeping track of the current child workflow that's running. And if it has a current handle for a child workflow, it's just forwarding that signal on to the child workflow. And the only thing I didn't show you was that not only did that pause button pause the currently running workflow, but if we go over to schedules, I click that pause button, you can see that's now paused, which from the client side is also very, very easy to do. So let's jump over to the server. Again, took me a handful of hours to write. You have your codes parent API that signals with start. If you never used it before, it's just a lazy way to initialize a workflow. If it's not already running, when you call signal with start, it'll start it up. If it's already running, it'll just send the signal. Very useful. The scheduled workflow doing the same thing, it's just doing a different type. It's doing the pending promotion code workflow that we then drain jobs from. And then pause, in this case, does a couple different things. First thing it does is it gets a handle for the schedule itself. Then it checks to see if there's a current run of the schedule. If there is, it'll take that, signal it an execution state to stop, and then the very last thing it does is pause the schedule itself, and then the unpause just reverses all that. So I mean, I didn't count the lines of code, but it's probably all in all about, you know, between 200 and 300. All of that and that ease and the primitives that Temporal offers out of the box make it incredibly easy to have fine-grained control over some of these batch executions. When you can't control user behavior, you can control the way you execute. Thank you. I think we have time for questions. Yeah. Tests within this? No, I didn't write any tests. No, this is just a simple demo. No. In this case, it was a manual pause, and that was more of an illustration. We're not actually using that feature today. Most of our monitoring is from the out-of-the-box stuff that Temporal offers through the Prometheus metrics. So we're tracking schedule to start latency and max concurrent executions to figure out whether we need to scale our workers or not.
Can folks raise their hand if you have a question? I'll run a microphone over to you. Just say your name before you ask the question if it's okay.
Hi, I'm Max. Do you ever have to deal with signal limits per execution, like 10,000 signals when you're using workflows as a queue?
Yeah, so if you're doing it over long periods of time, you can bump up against the max action limit of a given workflow, and that's when you would use continue as new. So if you start bumping up against that limit and getting the warnings, you spawn a new workflow, continue as new, passing your current workflow state to the new one that you've spawned.
Hey, so I was wondering if you could comment a little bit about your initial framing. You were talking a little bit about how you redesigned the workflow so that you can manage congestion by serially executing these workflows instead of in parallel. Um, as someone who's fairly new with Temporal, are there other levers that you have to manage congestion controls? Like, I mean, like limiting the number of workers or anything else?
You can limit your number of workers, and Temporal does give you some levers for concurrent task executions. So you can shrink that down if you really wanted to throttle the rate at which you're executing. But that's all, when you configure your worker and start it up in the code, those settings are in your worker options.
Okay, a couple of questions down the back. Bear with me for a second. I think these are just Temporal employees just messing with me, but yeah.
I just wanted to see Dave run. I'm Taylor. My question is, how did your team decide to go with such an innovative approach, and how did you get approval from your managers to use multiple workflows in conjunction?
So it helps that we've had other successful use cases. So we aped a little bit of the store and menu use case. I didn't talk about it because we reviewed it last year. But store menu, the way they author, is very similar. They don't necessarily want to restrict user behavior. We can have 2 users authoring menu updates for the same store at any given time. The question is, how do you adequately make sure that they don't clash and override each other, and we treat them as a first in, first out? So the way menu did it was each store has its own parent workflow. Its ID is the store number. And as it's getting authoring requests, those are getting queued up, like I showed you, within that parent workflow. They're added to that array. They're drained in a first in, first out method, spawning those child workflows until all the authoring requests are completed. And then once they're completed, it publishes the finalized menu out to S3 in a much similar vein to what we're doing. So.
I think that's all the time we have for questions for now, but Mitch is going to be available afterwards if everybody wants to follow up. So thank you, Mitch.
Thank you.
Yeah.